Welcome back to the channel in Coordinator Tech. I am Gagan and we'll be seeing linear search today. We'll find out what's the algorithm and what's the working behind it. We'll try to see what's its time complexity. And then finally we'll try to code it after knowing how it actually works. So we'll try to accomplish all these things within a span of 5 minutes. So without any further ado, let's start. First, let's see how linear search works, taking few cases. So here, case 1, we are trying to find x, which is 20, in a list. Here this list is of 1, 2, 3, 4, 5, 6, 7. This list has 7 elements. So we are trying to find the element 20 among this list. So how does linear search work? Initially, we'll initialize a variable incrementer I, and we'll initialize it to the first element of the array, and then we'll check whether the element which it consists is equal to the element which we are finding. Here I'll check whether 5 is equal to 20. Since 5 is not equal to 20, I'll increment the counter by 1. So now I will point to the second element of the array. Here I will point to 20. Now further I'll check whether 10 is equal to 20. Since it's not, then again I'll increment the incrementer by 1. Now I will point to 15. So likewise, I'll be incrementing the value of I by 1 each time until I find the element 20. So on incrementing one more time, I find that the element which I am finding is equal to the element which is present in that position. So then once I found the element, I'll come out of the loop. Returning the index position, that is I of it. Now what if the element which you are trying to find is not present in the list at all? That is case 2. In case 2, I'll try to find the element 21. So similar to case 1, first I'll initialize the incrementer to 0 so that it points to the first element. Since first element is not equal to the element which I am trying to find, I'll increment I. So now I will point to 10. I'll check whether 10 is equal to 21. Since 10 is not equal to 21, I'll again increment I. Now it will point 15. Similarly, I'll be doing that until the array ends. So I'll try to find here, it's not there, then I'll again increment it by 1, then again I'll increment it by 1, and then finally I will increment it by 1. Now, since again on incrementing of I, which will point to this location, now the I counter is greater than the length of the array. So, if the incrementer goes up to the n plus 1 positions of the array, then we have to return minus 1. Minus 1 indicates that the element which you are trying to find, here 21, does not exist in the list. So on returning minus 1, the user gets to know that the element is not present. So now that we got to know the basic idea how it works, we'll try to analyze the algorithm and then further see its time complexity. So here, this is the algorithm or the pseudocode for the linear search. Here we are here I is the incrementer. Here we are trying to increment I from 0, which will index to the first element, to n minus 1, which will index to the last element. Now for each and every iteration of this loop, I'll check if the list of element index is equal to key. That is, I am checking if each and every element in the list having the index I is equal to key or not. If it is equal to the key, then the element which I am trying to find is present in the list. Then I will return the position of the element. That will be the ith index. So I will go around this loop until n minus 1, until I reach the last element. Now after reaching the last element, I get to know that the element is not present in the list. So once I get to know the element is not present in the list, I should return minus 1. This minus 1 indicates that the element which I am trying to find is not present. Now that we got to know the algorithm, how it works, we will try to find the time complexity using theoretical method. First, we'll try to find the basic operation which we are doing. Here, the basic operation is the operation which we are doing on each and every iteration. Since in each and every iteration here we are comparing, the basic operation would be the if statement which is inside the loop. Now, how many times the if statement is being executed? That will tell C of n. Here we are executing the comparison operator inside the for loop for I is equals to 0 to n minus 1. So this C of n, that is number of times, would be I is equals to 0 to n minus 1, which will come to n minus 1. So the basic operation here is the if statement, that is comparing, and the number of times which are executing the basic operation is n minus 1 times. So here what do we get to know? We get to know that as the n increases, the number of times the basic operation being done also gets increased. So the time complexity here depends linearly to the input size. So if we have a very large array, it would probably take larger time. So this is not a good way to search an element in an array. So that's the reason we have binary search. So now that we got to know its time complexity and the algorithm behind it, let's try coding it. And now that we know the algorithm behind the linear search, we will try coding it. So here in the main, I'll create a list, here integer list of some 3 elements, 10, 20, 30, and then I'll find the key element, and I'll also initialize the key element as 20, the element which you have to find. Now I'll call index. I'll call a function linear search and then pass the arguments a and key to it, and then since it returns the index of the element, if it is fine, I'll place it into the index variable. Now I'll write the function of the linear search. Here, since it's returning an integer, return statement would be L followed by the function name and the parameters. Here it would be int a, that is the list, and then followed by the key. So according to the algorithm, we have to iterate to each and every element. So we'll do that using a for statement. For int I is equals to 0, I less than len of a, and then increment I by 1 position. So iterating each and every time to the array, we have to check whether the element is equal to the element if the key. So that I'll do using a if statement. If a of I is equals to key. See, now if it enters this if loop, if statement, then we get to know the element is found. Now I have to return the index. That is done using the return statement. Return I. So if on each and every iteration of this loop, if the return statement is not being called, then the element is not being found. So after this for loop executes, and if no return statement is encountered, we get to know that the element is not there. So that time we have to return -1, which will indicate that the element which you are trying to find is not present. So that's all. This is all linear search is about. So if you have liked this video, please like, share, and subscribe to our channel. And further, we'll be discussing on more such algorithms.